Today we're going to talk about congruent triangles. So first off, if you look at this chart right here, you can see if you have a picture of two triangles that are congruent, okay, they told us triangle ABC is congruent to triangle DEF, then you know that angle A is congruent to angle D because if you notice, A and D are in the same spots. Those are corresponding angles. Angle B is congruent to angle E because B and E are in the same spots when in the triangle's labels. And then C is congruent to F because they're in the same spots. The way you write out your triangle congruence is what will tell you which angles are corresponding because they're in the same spot on the triangle. Okay? So if they're corresponding and the triangles are congruent, then those angles are congruent. The sides are the same way. Side AB is congruent to side DE. BC is congruent to EF, and AC is congruent to DF. Okay? You can get a lot of information just simply out of the congruent statement. You can also see it labeled up here. The same thing goes with any polygon, anything that's with the same amount of sides. Okay? So you can't compare a triangle and a rectangle because they're obviously different figures. But these two rectangles, you can know which angles correspond with each other and which sides correspond with each other based on the order of the letters. From here, we're just going to do a little bit of review. Okay, so classifying triangles, the first thing is by the angles. Well, this triangle right here, we can see that all the angles are less than 90 degrees. So this would be an acute triangle. Okay? Now, this one right here, let's say I gave you that this is a 90-degree angle right there. Okay? If you have one right angle or one 90-degree angle, this is now a right triangle. This next one right here, this angle is greater than 90 degrees, and so that makes this an obtuse triangle. Since it has one obtuse angle, it is an obtuse triangle. And this one, if all three angles are 60 degrees, we call this equiangular. Never have a triangle that all the measures are the same, like an equiangular triangle, unless they're all 60 because all three have to add up to 180. Now, if you're classifying by the sides, well, if you know that two sides are congruent, then we would call that isosceles. This one, if all three sides are different, we call that scalene. And this one, if all the angles are the same, then all the sides are the same, and this is an equilateral triangle. Okay? So you should have learned those a long time ago, but that was just a little review. From here, we're going to talk about classifying triangles by its angle measures. Okay? So if you look, you were given, this picture has three different triangles in it. Okay? So you have this triangle right here, and this big triangle right here. Okay, so you can see there are three different triangles in this one picture. Okay, so what you can do is we know if we look at this whole big pink one first, we can see that this is a right angle right there. So if it's a right angle, it's automatically a right triangle. Okay, so triangle CDA or ADC, this is going to be our right triangle because we saw that right angle. Now, if we're looking at triangle ABD, well, ABD is this one right here. We have 150. If all the angles have to add up to 180, then this one has to be 30. Well, 100 degrees is greater than 90, so that makes this an obtuse triangle because it has one obtuse angle. And then BDC, well, if this angle's 30 and this one, the whole entire thing was 90, 90 minus 30 leaves us with 60 degrees for this one. Angle C was 40, so angle CBD has to be 80. All are less than 90 degrees, so this would be called an acute triangle. Now you want to make sure that you can see all the different triangles in here because seeing the picture can be the hardest part. The next one is we want to classify the triangle by its side lengths. Well, again, GIJ, triangle GIJ would be this big triangle right here. Okay? Now, this big triangle, we can see that if these two are congruent, GI is not congruent to JI. They've also listed GJ as 6.9, and this whole big triangle has to be scalene because it doesn't say anything is marked congruent, so we would call this a scalene triangle. You don't know anything about its angle, so you can't classify it by its angle. Then you can see all three side lengths are marked the same. And so if all three have the same tick marks, then we know that this is an equilateral triangle. And the last one we're going to look at is GHJ. And GHJ, you can see that two of the triangles have that same tick mark, but GJ is 6.9. It's not marked with these same tick marks right here, so we know that this one would be isosceles. So from here, you're given a triangle and it has some markings, and we're supposed to identify what the side lengths are of each triangle. Well, if you can see, this is an isosceles triangle because this side and this side are marked congruent. Well, so all you're going to do is put those two sides equal to each other because we know their measures equal each other. Side lengths do not equal 180, okay? So many times people try to add up all the side lengths and put them equal to 180. That only works with angles. So for the sides, we're going to put our two legs congruent to each other, and x equals 0.9. Well, if x equals 0.9, then you can plug this back into each side, and you end up with 0.9 plus 1.4 gives you 2.3. 3 times 0.9 minus 0.4 gives you 2.3, and 0.9 plus 0.1 gives you 1. Now, if you plugged it back in and these two sides were not congruent, then you know that you did something wrong. For the next example, we're told that the distance as the crow flies, that just means if you're flying straight there, you're not taking roads or different things, you're just flying a direct shot as the shortest distance from Santa Fe to Phoenix is 609 kilometers. Okay? Then it tells you this is 245 kilometers less than twice the distance between Santa Fe and El Paso. Well, do we know what the distance between Santa Fe and El Paso is? No. So I'm going to go ahead and call that x. The this is talking about the 609 we just mentioned. So we could say 609 means equals 245 kilometers less than. If it's less than, you took 245 away from whatever comes after it. So we're going to have to switch those. So I'm going to go ahead and draw arrows. And it's a minus. Twice the distance between Santa Fe and El Paso, well, we don't know it, so we're going to call it x. So essentially 609 equals 2x minus 245, and 427 equals x, which means that from Santa Fe to El Paso is 427 kilometers. Now, it then tells us Phoenix is 48 kilometers closer to El Paso than it is to Santa Fe. Well, if it's 609 kilometers to Santa Fe and it's 48 kilometers closer, then it's going to be 609 minus 48 would be your distance from Phoenix to El Paso, which comes out to 561 kilometers. Okay? You're told that triangle CDE is congruent to triangle HIJ. Now, the first thing is you want to go ahead and draw those triangles. You don't know what kind of triangles they are, so just draw them. However, doesn't matter, because you know that pictures are not always drawn to scale, because as we're drawing these pictures, we don't know what's to scale. But if you were to go ahead and label them, and we labeled one of them C, D, E, and then we know that C is corresponding with H, so I would label this one H. I corresponds with D because they're in the same spots, and E corresponds with J. Okay? So if those are congruent, we know that CE is congruent to HJ, CD is congruent to HI, and DE is congruent to IJ. Okay, a different number of tick marks tells you they're different lengths. Okay, so now we know DE is 9x, and we know that IJ is 7x plus 3. Well, we can see based on how we marked our picture that DE and IJ, those are congruent. They both have 3 tick marks. So I could now say 9x equals 7x plus 3 and solve. And x equals 3 halves. Well, if x equals 3 halves, now we're told to find DE. Well, DE for 2. Okay, so